Did you guys see how I was able to watch this 3-petaled rose graph twice and the circle only graphed once? I had that little circle feature selected. So I know this one is going to have a 0 to pi to do the entire shape, and this one is going to have a 0 to 2 pi to do the entire shape. True? Okay. Area common. I have this guy going basically here. I should probably watch it graph one more time. So I was paying attention more to how much of it was graphing than to the order. It goes up, then it goes down, and then it goes around. Okay. Goes up, and then it goes down. And that's going to complete in 0 to pi. And then I have my little circle over here to the side who's doing his whole like thingy. Okay? If I want the area common, doesn't that mean that I definitely want these, which symmetry is a great thing in polar. I want these 3, right guys? Yeah. Okay. I'm going to go ahead and zoom in on one of them, just so I can see what's going on. So off to the side, that's green. How did that happen? If I zoom in on this, I go ahead and see from the origin, I see my rose leaf, and then I see my circle. Okay? When I do polar area, this was starting at 0, and guys, if all 3 petals graph from 0 to pi, doesn't that mean that I'm going to have a petal from 0 to pi over 3, right? Okay. Knowing that it started out and completed. So 0 to pi over 3. Couldn't we also find that by setting that equal to 0 and sine of 0 at 0 and pi and 2 pi divide by 3, but it might be easier just to kind of use logic. When I do polar area, it goes from the point to the edge. Who am I going to right now? No. Who am I being hit by? Yeah, the petal. So to start off this region, I can't go straight to the circle, because if I go straight to the circle, won't I have lost? If I go straight to the circle, won't I have lost some of the area? I need this and that. Going to the circle will get me this in-between part, but it won't get me that curved part. And I know it's kind of hard to see there. You're like, what? It's the same thing. No, it's not. There's extra area right there. And then we come back to the petal or the rose again. So what marks the difference? This angle line of, wait a minute, that's not pi over 3. Who's that? And this angle line of, who's that? Not pi over 3, because pi over 3 was the whole thing, remember? So what do I have to do? Find the intersection point, aka figure out when this petal hits 2, right? So can't I off to the side say, okay, 4 sine of 3 theta is equal to 2, sine of 3 theta is equal to 1/2. Isn't sine 1/2 at pi over 6 and 5 pi over 6? So 3 theta is equal to pi over 6 and 5 pi over 6. And I guess we could keep on going, but hold on, positive 1/2. That won't happen again until I'm all the way around 12, 13 pi over 6. Anyway, I could keep going, but the long story short, don't we have to divide everybody by 3? Yeah. So the first one is going to happen or occur at pi over 18. Now, what if you're paranoid and you're like, I'm not sure that's right? How could you use your calculator, maybe not to find the intersection, but to at least check the intersection? That actually is what I would do next. To check it, I would just do trace, and I would plug in pi over 18 and say, please be at the intersection, please be at the intersection. Oh, look, it's at the intersection. But why did Maggie say function mode? Because that's totally valid. Function mode can do zeros and intersections. So function mode, I can technically take my equations and say, well, you know what? I have sine of 3 theta, and I have 2. And I can look in my window, I can look between 0 and 2 pi, because that's my window for my thetas, right, my x's. I can say, hey, when do you intersect? Now, it's not going to be nice and pretty like a pi over 18, but do you guys technically need a pi over 18 for this multiple choice matching? No, a decimal would be just fine. So couldn't you technically do second, well, actually, you know what? I know that this is going to be in between 0 and pi over 3, so I could even just make my life a little bit easier and have less region to worry about. There we go. That's the guy I want. Oh dear, this is taking forever. If I was to stop it right now, you guys realize that you have to have it graph entirely before you can go do intersections and zeros, right? But if your graphing calculator is thinking, you're like, no, I did something wrong, realize on breaks it and says, just stop what you're doing, just stop. That's on. Enter says pause. Enter says pause, like I need to see something, okay, go again, or keep going. On just breaks it and say, just stop. Okay. I can go ahead and do my, we could do zeros and the subtraction and all that. Since I can see this one, I think I'm just going to do intersect. Guess what pi over 18 is as a decimal? So you could go ahead and stow that, yeah? If you wanted to. And you could just make it whatever and not even know that it's pi over 18. But is it pi over 18? But some of you are like, I don't do good with the trig. Did you have to do all of this mumbo jumbo over here? No, you could have just graphed it in function mode and found your intersection point. It's going to work just fine. What are we going to use that for? Well, let's go ahead and plug in. Because for my area, I need 1/2 the integral from 0 to pi over 18. Who am I going to? Or from 0 to a, if you did it that way. Who am I going to? Don't we already have this plugged into our calculator? Can't I just use R1 or Y1 or whatever you want to use? R1 squared? Saving time, yeah? Plus. Okay. Now what? You guys don't need me at this point. Come on, I gave you everything. Now what? That'll get me, yeah, this little piece though. And then I need more area, so how do I get more area? How? Good. Of the circle. Does that make sense? Because that'll get from here to, and then Justin went over there and said, okay, pi over 18 is one, 5 pi over 18 is the other. Wait, if you didn't know the trig, if you didn't like the trig, what could you do on your calculator right now? Go find the next intersection point. Do you see it? Make that B. Go from A to B. It's okay. It's a calculator problem on purpose. But I'm not done still. What do I still have left? Sweet. So you could just be like, well, forget that. I'm just going to, and then get one on that side, one on that side, done. That works. Or you could have gone from 5 pi over 18 to pi over 3 back to the circle again. Does that make sense? Just curious, how many of you guys are actually doing the, like, using y1s, y2s in things like integrals or derivatives when you're using your calculator? Okay. I know you don't always have to graph it, but if you're graphing it, it saves so much time. On FRQs especially, just to use the y-vars, okay? And it eliminates the possibility of you plugging in something wrong. There were at least a few times in BC where I'm like, your formula's right, I don't know what happened. Right? And it was like, choo, choo. So be using things like that to eliminate error. Are we okay-ish on what's going on? Does it make sense? If not, we can keep practicing, but at least gives you that one. Was there anything else in the packet as far as FRQs you guys wanted to see? Because I think we got through multiple choice. Which one? This one? What'd you get for your horizontal tangents, kid?
I got pi over 2.
Yeah. Horizontal tangents? Because you have to think, oh, hold on, let me get rid of this black marker. You have to think of x prime and y prime, but when thinking about x prime, y prime, horizontal, remember they can ask horizontal or vertical. understand. The color red is not the color red. Okay. Sorry. Thinking about your dy dx, this guy equal to 0 would be my vertical, and that guy equal to 0 would be my horizontal. But they can't be shared. So I would go ahead and just find y prime. Now, if you have your formula memorized for r prime, or for r of theta dy dx, with like the r's and the, what would that be? Oh, with the r's and the cosines and the sines, right? If you have that memorized, just take the numerator. If you don't have that memorized, you could totally just go off to the side and say, okay, y is equal to r sine theta, right? And then you just find your y prime. When you find your y prime, second d first, it's going to be -3 sine cosine, I think, right? Second d first, 0 minus 3 cosine, plus first d second. Either way, you should end here. At which place, if I'm trying to find zeros, oh, calculator allowed, forget that. I mean, we could go doing stuff, but couldn't you also theoretically just go plugging it in, finding the zeros in function mode? But just in case, it would be helpful to have the trig and the nice, like, perfect little radian answers. I could go ahead and pull out a sine of theta, but I think this is going to be nasty. So I get -3 cosine of theta plus 1 minus 3 sine of theta. I don't see that being anything nice. But Maggie, you said something nice, didn't you, from yours?
Yeah.
Oh, these ones are nice, I guess. So that would be pi over 2 and 3 pi over 2. Oh, as your derivative?
I got it right.
How'd you do it, Ken?
I simplified. I plugged in R beforehand, and then I took the derivative. So like kind of what you did.
But you simplified first, so you got sine of theta minus 3 sine squared of theta?
Yeah, and then I took my derivative.
Oh, okay, so it would look prettier?
Yeah, so it looks prettier, so then you're able to like see the difference.
Then you can do 6 sine theta cosine theta.
Yeah, and then I pulled out the cosine.
Oh, that's way easier.
Yeah. And then you get, 1 minus 6 sine theta. And then so you get pi over 2 and 3 pi over 2 for the cosine. And then I plugged in 1 minus 6 sine to my calculator to find where it's 0. And then you get like
Some decimally answers.
Like 0.167448.
And Riley, this is gross too, because technically when it's saying find the angles, there are infinitely many. They should have given you some sort of range. That's just where it's a non-AP question. They should have said 0 to pi or 0 to 2 pi. Something like that too. But that way too, when Maggie goes looking for the 1/6, she could limit her window and get there. So what did you get for these guys?
0.1. I don't. Do I round them? That's what I was confused.
I'll just do a dot, dot, dot. I would have stored it probably.
0.1674. And then 2.974.
Okay. So now we're up to letter B. One of the horizontal tangents occurs at a point x naught, y naught in quadrant 1. Pause. We can use our calculator, true? Shouldn't we be able to see horizontal tangents because the curvature is flat? Or you know what I mean, like the tangent line would be flat?
Yeah.
So then if I was to go ahead and go throw this in polar mode.
I think my biggest confusion on this is I'm not really sure what they're asking for.
Yeah, I'm just trying to get a visual so that we can see what where they're asking. But no, you're right. 1 minus 3 sine of theta. When they say in the first quadrant, I can technically, this is zoom standard. Oh, that's all there is to it. Okay, it says first quadrant. I'm going to zoom in first so I can get closer to my figure. But you could technically even zoom in further and just look at the first quadrant, which is kind of awkward, but if you notice, I could make my window something like, let's see, that's my y max, right? How about something like 0.5? It does go above, so there is a little baby portion. And limestons were kind of used to them jutting out anyway, right? They cross through the axis and then they come into the zero and then they cross through. So they're saying there's a horizontal tangent, and technically, I don't know about you guys, but I can totally see, oh, sorry, because of the glare. I can totally see the horizontal tangent. It's right there where it has a maximum. Oh, sweet, no problem, find a max. Don't find a max. See, so we have to have another way of getting to that because we can't just use the max feature in polar mode because it doesn't graph in a similar way. So how do we find that guy is my guess, but let's go back to what they're asking. There is a horizontal tangent occurring at a point. It's like, okay, I see it. Write an equation of the line that passes through the origin and that passes through that point. Oh, well, okay. I mean, guys, you can make an equation of a line through 2 points. The point is you have to find him, right? So we need to know the horizontal. Okay, so which one is going to help us out is basically what they're asking.
It's basically like saying use your answer from A, but it's not giving you the answer.
Right. Right. Well, these are thetas, right? Sorry, I put x. These are thetas. So hold on. Didn't I just show you how to use your calculator? What can you do to each of those? Can't you trace it? I mean, you can totally cheat and be like, hey, which one of you is the right one?
Is it a 0 where x doesn't equal 0? Is that what it's equal?
Well, we can think of it this way. All the ones that Maggie gave me were between 0 to 2 pi. So if I go to my graphing calculator and if I go to my window and make it 0 to 2 pi, and if I have that cool little circle-y-do selected as my graph, I should see if it goes over that point twice. See what I mean? So I can see that I think this limason, it's going to complete right back at the beginning. Got it. It didn't go around again, so there's only 1 point. And specifically, I can actually also tell that occurred right away, which means it's the smallest value. The smallest value, my guess, is this guy, 0.1674. But how could I know for sure? Guess another way of doing it. Don't you have to find x and y anyway? I'm going to start finding x of that guy and y of that guy. Guess what's going to happen to both of those? The x and y is going to be positive, which means he's in the first quadrant somewhere. Guess what happens when I start plugging in x and y, x and y, x and y? Either they're going to be zeros, like one of them is going to be a 0 as far as the x or the y, or one of them is going to be negative. This is the only point when plugging in all of those thetas where x and y are both positive. But I could kind of cheat and do it in my calculator also. Because if I find the zeros, then I can go ahead and just double check myself and say, okay, so 0.1674, are you? Yeah, you are. Gotcha. See it? This is the horizontal tangent. But without finding the horizontal tangent with this math, we would have no way of knowing precisely where it was, at least as far as how to use the calculator. Oh. Mm-hmm. Well, x of, we can plug in your cool quantity, which, I mean, I guess I have most of the decimals. I don't have all of them since I didn't find it. Yeah? Okay, so can't we plug in x is equal to r? Hey, don't I have r just chilling? Let me use him. R of, Maggie, what's all the decimals? 0.167. I think that's enough. Okay. Oh, 8, got it. So isn't x r cosine theta? Maybe I'm going to be lazy and do 0.1674. What was it? Yeah. I'm just trying to still them because I don't want to type them out over and over again. So x is going to equal r theta cosine theta, right? See, I just didn't want to have to type it over and over again. There's my x value. And then y is going to equal r sine theta. See it? So what did I just find? My x and my y. And what do they want? An equation of a line between the x, y of this and the origin. So rise over run, which from 0 to Y is the rise, and from 0 to x is the run. I don't even have to worry about it, right? So I can say y minus the origin is equal to x minus the origin, and I can do my, my y2 over my x2, which is going to be y is equal to, and then coming back to my calculator, why not just divide the sine quantity by the cosine quantity, 0.169. Yeah. It wasn't exact. Did you find the zeros of the function to be the beginning and ending of the loop? Naomi asked me this the other day, like, how do you do the inner loop? Well, the loop always starts, and Justin, you asked this too, starts with a 0, ends with a 0. So what'd you get as your zeros?
My bounds, I put 0.339836, and then I used my last theta that I got from off of from part A.
Careful, I think you just want your r to equal 0. Were you doing like x or y equal to 0?
Maybe that's what I'm a little off.
I think that might be why it's a little off.
So I got 2.53, and I think the answer is like 2.5 something else.
Because if I were you, I would have gone ahead and just probably in function mode. But you guys are seeing me go back and forth, and that's necessary on polar sometimes. I would have just done my sine of theta, and I would have done my 1/3. Or you could have done like the zeros too. Intersection, I know it's not going to go very high. I'm going to go between my 0 to 2 pi, one cycle around. Graphing my polar curve. I'm just seeing where the inner loop happens. The inner loop happens like right away. Okay. So in my function mode, these are my bounds for my inner loop. This guy and this guy, because this is when sine is 1/3 and when sine is 1/3, which is what we're looking for as far as the zeros. Oh, I want to go over here. So one of them would be 0.339.
Yeah, I got that.
And the other guy can be...
See, in their analysis, they put pi minus that number.
They're just saying, because they understand how sine behaves, they know that sine is the same in the first and second quadrants. So to get there from the second quadrant is to do pi minus 2.801. Hello? Okay, thank you. James' office buddy, I think you're leaving. So Maggie, with that small difference, I bet that makes all the difference in the world. So then throw that into your 1/2 r squared. Oh, when grading it? I don't know what they gave you points for. Did they give you points for the integrand?
Yeah.
So you get the integrand if you did 1/2 r squared, but the limits, you wouldn't get the limits.
But it says with constant.
With constant would be the 1/2. So you just missed the limits point.
And the answer was
Yeah. So I didn't know there was 3 points. Bye, James. Okay, any other FRQs?
yeah, wait. That's D on number 3.
Ooh, we have all kinds of pedals because it's, you guys remember even number double pedals, right?
Yeah.
Inside but outside.
For D?
That's okay, let me just write it out. So inside but outside. Inside which one?
Inside.
Circle.
By R2.
Outside the rows.
Yeah.
No, that doesn't make sense. Inside.
Circle, but outside of that. It's like a little too.
Is that right? Yeah. Like you would keep on counting around. I'm just going to be lazy and do symmetry. Okay.
I hate the wording when it's like inside this one but outside that one. I feel like I'm gonna always look for the wrong thing.
I'm trying to think if there's a strategy for it. Well, like what I just did. What I just did was inside the rows but out. Like just think of coming in and going out. Like you're just going to have to, because what I first did, I was like, wait, that's inside the rows and outside the circle. Like that doesn't make. So inside the circle, think of everything, and then like I would take the first step and just do everything, and then go ahead and take the second step and subtract out. So I think what your brains are trying to do are go straight to a region, and you're not truly thinking about it. So inside the circle, my brain should have been like, hey, it's everything inside, and then take out the petals. Okay, fine, take out. Ooh, there's a little sliver, and the little sliver is awkward, which is why I zoom in, because it's going to be like a voomp, 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 basically, right? Okay. So with my voomp, 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 whatever that is. Okay. I have my circle out here.
For D, my problem is that like I can find the bounds, and I know like
The intersections, right?
yeah, like you find them just like setting it equal to each other, or like setting it equal to 0. Like I got those points on the FRQ. My thing is like I don't know how to set up the integral. Like I don't know
Right.
how to work it.
That's why I have to zoom in for my brain, and that might be what you need to do too. Because in my brain, I need to think about just this piece. I don't know why it's not registering. I apologize, guys. Here's my circle, and then this is the red's all my rows. So if I do my intersection point, which would be what you found it to be, this angle, see how it'd be too much? So then I'm just going to call this theta equals A and theta equals B, because you're exactly right. Just use the intersections in function mode, and it's the first two as far as that region. I'm just going to multiply once I find it by however many of these slivers there are. But as far as the area, if I go to blue, there's no way that registered blue. Come on. Okay. If I go to blue, do you see how it's going to be too much? And you just have to think of radial lines. Radial lines mean just straight out along the radius, straight out along the theta. The radial lines are good in that it's going to be the bigger area, so I could do my 1/2 from A to B of my 2 squared, or my R2 squared. But I need to subtract. And then I go ahead and come back and I say, okay, what do I need to subtract? I need to subtract going to my rows. Now, here's a little bit of a struggle. I think I would do what James said a second ago. I would just double as soon as I got one and just leave it at that, because I need to do it on both sides. But then as you're drawing the rows, just be careful as to whether it's, I guess whether it's 0 to A or A to 0. It should be the exact same thing. I would just double check that your row starts graphing like this. I'm guessing your row starts graphing like that, but I think you should be able to do 0 to A as well. There was only one FRQ that I have ever heard of. Well, because there's one, they might have just done a half instead of a whole. 2, 3, 4, 5, 6, 7. Okay, there's 8 total. They might have only gone halfway. But I did the whole thing as far as this sector. I'm going to subtract the whole thing as far as, so I only need to multiply mine by 8. But if they only went halfway, they might be multiplying it by 16.
I was confused by the answer completely. Like, really. And oh wait,
I would subtract.
You do 4 pi minus m. I don't know.
Okay, ignore them. I would have to graph it to know exactly what's going on as far as the rows, so hold on, give me a sec. 4 cosine 4 theta, right? Just because to make the bounds for the polar curve, 4 cosine 4 theta. And then the circle's 2. I need to look at my circles. I'm going to go ahead and do it in the first quadrant just because I know that I need it in the first quadrant. I'll graph and then look at it. Okay. Do you see how this guy at 0 was out here and came into here?
Yeah.
So that's my A, and then A to, A and then B is up there. Maybe I wouldn't have done the whole doubling of things. Because if A and then B, that could just go ahead and get both those slivers that I want. I think I would take away the 2. So I think A to B would go ahead and get me that one. Thanks, buddy. And then that one. So then that would go ahead and be R1 quantity squared d theta. Which I would find to be 8 times. The 1/2 can come out of both, so that'd be 4 times. Then I'd have my function integrate from, you'd have to find your intersections. Sorry, I was going to plug it in and see if it checks. So Maggie, we can check that one out and see. I'll bring up the answer key during period 5 and then check it. Oh, nope, I'm being Mrs. Leon during period 5. Just kidding. I think, though, guys, with that, we need to be done with polar area as far as an LTF packet and questions. But that doesn't mean that you don't still come approach me as far as personal questions. You guys have an LTF number 2 from me that's being copied off at some point tonight, today, tomorrow. So you guys will get it at some point either tomorrow or Monday as far as us looking at the extra practice to logistic and Eulers. But we're kind of getting into the danger zone of being too narrowly focused as a class. Focused individually based on what you have found evidence for are your weaknesses. Does that make sense? So to that end, we are going to go ahead and end the LTF questions today. Tomorrow we're going to go ahead and do part A. Monday is going to be part B for those that are here. Who's gone Monday for AP? Gov? Is that Gov on Monday?
James.
Okay. We'll be going over part A questions on both mock APs tomorrow, part B questions on both mock APs Monday, calculator FRQ questions on both mock APs Tuesday, non-calculator multiple choice, FRQs on Wednesday. The Forever Endeavor final is on Thursday with the mock corrections hopefully being done by then, at least on the one that you did. And maybe you have the bonus exam done by then also. And that way, hopefully Friday and the weekend, you could go specifically looking at, I need to go get me some differential equation practice. I need to go get me like a whole FRQ section from last year, from 2 years ago, from 3 years ago to practice on. And guys, for the bonus exams, I'm going to tell this to AB too. Those free response questions, they're not an entire year's worth and an entire exam's worth of bonus, but if you do an FRQ section, I'll give you half the bonus of a test. I'll give you a +2 in that test category. So you can go to any of the previous years of FRQs, and I know I just gave you an unlimited amount of bonus. I didn't mean to. I probably have to put some upper bound on that. But if you're like, I don't need practice exams, I just need practice FRQs, go grab a year, grab 2017, 18, 16, print it out and try it. Grade it, correct it, come ask me questions as you need. Sound good? Any questions as far as logistics?
Since I have psych on Thursday, can I take the forever final after school?
Yeah. Anybody else in psych? Okay, so forever final, maybe after school on Thursday. Next Thursday? Okay. If you guys have individual questions, let me know. But otherwise, your goal is to have the other mock AP taken, graded, and then start trying to do corrections yourself. I know some people were working on them yesterday, but even on your exam, start looking at your exam, and that way we can narrow down, hopefully, and only hit the really hard ones tomorrow. Part A, Part A, Part A.